All right. This is a talk about how Yocto does validation in a very broad scheme. It's not going to get down into a lot of the individual tests or anything like that. This is something I think the project actually doesn't do well as far as showcasing what it actually provides. So um, it, what I'm going to be talking about, this would not be possible without the gracious contributions of the Yocto Project members. They help fund the infrastructure and all the resources that had made all this happen. And uh, over the past 10 years, all those contributions and work have created what I'm going to be talking about. And of course, we get lots of community support out of this whole thing with help from the community, I guess. So I'm going to go over the continuous integration, and then I'm going to cover the quality assurance aspect, and then at the end, I'll cover a few extra things. So our continuous integration is called the Autobuilder. It was referred to in some talks done earlier yesterday. The technology is BuildBot, sorry. And the initial version of this, the version 1, was done back in 2012. In 2018, version 2 came out, and it actually separated out the BuildBot high level stuff from the lower level stuff that we needed that was very specific to the Yocto project. Before, it was all mangled together. It made it very hard to maintain. And this separation allowed us to easily update to newer versions of BuildBot, so you could take advantage of security updates or any other new features. And I believe we may have done 1 or 2 of those since the version 2 update happened. The builder, the Autobuilder, is publicly available, viewable, I should say, and it's at this URL. I don't know how many people have been there. This is the landing page for that, and if you go to the bottom, you can actually. This is kind of what it looks like. All the builds that are happening gives you a little. On the left-hand side, you can kind of navigate through pieces and drill down if you'd like to see more of what's going on. We have workers. We have x86 workers, and we also have, I believe, 1 ARM64 worker that we run the builds on. We do a wide range of hosts. We do the Red Hat combination of CentOS, Fedora. We have Ubuntu and Debian, and OpenSUSE and Tumbleweed. So these are the OSs that we actually run on the workers. We have 2 configurations. One is for the controller, and I have the URL there. The code is publicly available for people to use. It's the Yocto Autobuilder 2, designating the 2nd version. The worker is done on a per branch configuration, and it's on a per. Each worker is a distro itself. It supports one of the distros I talked about earlier, and it's the code that runs on the workers is on the Autobuilder helper repo. Some terminology that sometimes we'll send out emails, the stable maintainers or whatnot will send out, oh, it, passed a quick, or it might use some terminology that people might not be familiar with. So I'm going to go over what a quick is. It's a quick test that can be run. It's roughly 41 different kinds of builds. It does all the machines types that we have. It'll do a multi-lib configuration. It adds muscle. We do 1 self-test build that I'm aware of. I'll go into self-test in a little bit later. It'll do runtime tests, but the fast P test. It's just a quick sanity verification that I believe Richard probably is the one that uses it the most. Maybe Steve for Dunfell. We also have an alt config. It's an alternate configuration. It's where we actually throw in systemd, PAM, and we'll actually have do one of the other kernel versions. In the past, it was the LTSI, but I think depending on the release, the actual version changes what we run. So the one that many of us use is A-Full. It's all of A-Quick. We've added 14 more build configurations. It's all self-tests. It's all the P-tests, including LTP. It does a couple other tests, build perf, and it builds the member layers as well. So if you're a platinum member, you can get your layer built on the Autobuilder. The use cases that we use the Autobuilder for is when we get package updates. This is where we check things out. If there's a new host that gets added as things evolve, as we drop off old hosts, we add new hosts. We use this to do validation. It helps us validate it. It's used for stable releases, the LTS release, and recently we've added the AUH. If people aren't familiar with that, that's the auto update helper. This is some emails that you might see when they actually do package updates. It allows you, it actually automatically updates the packages, does a sanity check on it, and sends out an email saying which ones applied and didn't apply. And then we also do, we've added Bruce so he can do kernel validation before Richard has to, it alleviates some of the pressure off of Richard running his own kernel builds on it. The builds, we generate quite a bit of artifacts. We have them separated out in non-release and release. And I'll show you. So this is what the releases kind of looks like. So you can see that these are the milestones and some of the Dunfells in there. And the current one that we're working on now is 3.2. So you can see the releases there. These are official releases. So you can drill down and see all the build artifacts or grab the build artifacts if you want to use them. The non-release ones are the daily builds that we might do. And they look, it has a different format to it. So these are all by build time. You can build stamps, I guess, and then it kind of tells you what the test was and has links to other various information that you can look at. So if Chem happens to be building meta open embedded, he can go look in here, drill down and see what kind of failures there may have been or what the tests look like. When we do official release, we'll pull stuff from the release area itself and put it on the official downloads page for the Yocto project. So the one that's on the Autobuilder is more of a staging setup, and then the downloads is the more of the official. Oops, wrong thing, sorry. We also generate shared states that we share with people. You can get that from this URL. It's actually commented out in the local.conf when you actually source your environment for building. And we also keep sources for the actual repositories. We have a snapshot. So when you might see a message saying checking alternate mirrors, this is Yocto Project is one of those mirrors that it checks if it doesn't get it from GNU or whatever. So we have copies of that. Some additional miscellaneous things that we generate. We have an errors. We have the ability to capture errors for builds, and we have a special website for that. So you can, so if you have a failure, you can look at, Oh, shoot. So here's an example of what an error might look like in the system. You can go look at it. This is what, my goodness, Richard or Ken might send an email back saying, hey, your package failed, and they'll provide a link of this nature that you can then look at and click on the failure. It tells you what package it failed on, some additional information on what kind of system, who submitted the errors, that kind of thing. So it's very helpful in the ability for people to understand what's going on when there's a failure. We also have build history. We archive that. I'm not going to show that particular one because I think it takes a long time to load up. We also have Wikilogs that we update on each build. We update our wiki, and this is what the SWAT team is, one of the resources the SWAT team can use when they help check out failures. Let's see if I have a link. So this is the build log, and so each build is in there and what branch, and you can click on it and it'll you can drill down and it'll tell you which failures you had, and this gets you back to the Autobuilder itself, so you can interrogate and figure out what the failures are. So all right, so that's all I have for the high level on the CI, and I'm going to go into the quality assurance. Basically, there's two kinds of QA categories. One is the CI. That's the automated tests that we do on the builders itself. And then we actually do have a formal, these are my terms, so it's a formal build process, QA process that we do. So this kind of goes into the history on how long we've actually had the ability to do testing in the project. The first test that I've been able to find landed in the repository around 2013. The framework that we use is Python based, but it's the unit test module is kind of the keystone for the whole thing. And we've got various groupings of tests. We have self-tests, runtime tests, we have the extendable SDK, and build perf. So regarding self-tests, we have two kinds of self-tests. We have the bit-bake ones and open the OE self-test. So roughly the bit-bake actually tests itself. You can run the bit-bake self-test. There's roughly 350 plus test cases that it runs through to make sure that bit-bake is working as expected. And we have a similar thing for OE self-test. These are tests that run on your host. They said they have nothing to do with the machines or QEMU or anything like that. These are all things that we run on the host. It's I view it as a nice way to help validate if you're running a host that's not necessarily supported by the project. You can run these just to get an idea of what problems you might run into. It's a good way to test out validation. And we have basically three test states. We have pass, fail, and then we have skipped, and it's an auto detection. So it will check to see if you have, let's say, RPM installed. And if you don't, like on a Debian system, you wouldn't. So then it skips the RPM test that it has. So you might see skipped. So runtime, these are run on a machine, and it could be a virtual machine like in a QEMU instance or on real hardware. These are things that you can execute commands on the virtual machine. You know, do PS, check check the parse logs, things of that nature. There are some special case tests. As I see it, p-test. And the reason I've separated the p-test out, it's a test within it's multiple tests within one execution. So these are tests per package. It has its own executor, which is called p-test runner, and currently we have, I think, 135 p-tests in core. And LTP is another special case because it's a test framework that runs a bunch of other tests. So it's that I kind of, that's why I separate them out as a special case runtime test. It also has a split. It's a split. I'm calling this a split results because it has pass, fail, and skipped, and there's a gray area that's associated with some of that stuff. The skipped actually is again an auto detection. It'll say, did you include a particular package in your image, so I can run the tests. So it's similar to the one for self-test. We do have roughly 25 SDK tests. So if you actually do changes to the SDK or ESDK, there's still tests you can run. It generates results and it's in the JSON format, and we dump that off in the temp logs OEQA directory. There'll be a .json file sitting there. And we do upload the results of when the Autobuilder is done, it actually then uploads the test results for use for later. So you can view those. Let's see if I have an example. Okay, so this is an example of a test report. So it'll tell you all the machines that it ran, because it'll collect the data of all the tests run, or all the machines run within that directory. So this is it'll tell you how many passed, failed, skipped. And as you scroll down, it starts getting into maybe machine specific. These are the p-tests for the tool chains, and you can, and these are all the p-tests for x86. Another test that I'm not sure if it's really a test, it's more of a performance thing. I think the only person that might use this is Richard and probably Michael Halstead. This is run on a couple machines, and it collects data on how long things to run and resource usage. And there's a wiki page, talks about how to, it explains kind of how, if you want to do performance checking yourself, you can run these tests as well, since we provide them in the layer. And we do upload the build stats. We upload all this into Git repo as well. So this is kind of it provides an HTML format, and I'm not going to get into how to read this because I think Richard is the one that probably could explain all this, but this is kind of what it looks like. So we can compare if something got checked in and he notices that things take longer or uses more memory space, or that he can then say, well, was there a commit that did that, or a design change, and was it on purpose, and that kind of thing. So he runs this in the background, and you might see patches from him saying this fixes, improves performance or whatnot. So I'm going to get into formal QA. Formal QA, these are resources donated by Intel and Wind River. Intel does Intel hardware, obviously, and Intel, from what I can tell, tends to be the lead, I guess, or the point, or the face of QA when we have questions. Wind River does the non-Intel hardware, which was it's the BeagleBone Black. It was the PowerPC board we had, and Edge router. So I'd like to thank Intel and Wind River QA teams for all their work. We do formal QA when the project has a need for an official release. And official release tend to be the milestones that we have during a development cycle. I provided a link to, if anybody's interested in see what one might look like as far as capturing what the milestones look like. So we've done that during the 3.2 phase. So we're doing a new release, and I believe right now we're running QA on the 3.2 RC2, unless we have an RC3 that I'm not aware of. We also run formal QA on the dot releases. So whenever Steve does a Dunfeld update, we ask QA if they could run a formal QA, their process on it. This formal QA provides an independent checks and balances. So they take everything, they do they don't they don't take everything from granted from coming out of Autobuilder. They go off and do their own thing. It's a great way to um, make sure what we're doing everything. They rerun the automated tests, and they add the manual tests. And the manual tests are part of the OE core tests themselves, and this is all done on real hardware. So they add in all the hardware testing. They also do regression analysis. So they use this script that we have, this tool called result tool, and it does comparison between tests. So we might, if the last let's say bind had 4 failures in the last release, and when they're doing QA now, if it has 5 failures, they say there's a difference, and they'll go off and investigate and try to figure out which one failed, why, maybe, and double check their work and report back on that. So let's see. All right, so we get an official QA result report. They upload it to Yocto test results contrib. Since it's an external activity, this is where Intel people upload the results. They open up defects on regressions. For those that are on the Yocto mailing list, they send the report off to the mailing list. And this is an example of the one for RC2. Kind of tells you the link that they use to upload things to. If they did it, they verified a few bugs, as you can see, and they had to open up new ones for new regressions. And then you can, so this is a mail, I believe, that went out earlier last week. So the last piece of this is these results get sent off to the Yocto Project TSC. They review, and if things look good, they actually approve that release and to move to the next stage. So all of that I've just covered has been running probably 5+ years on the project, and is probably why it's amazing how stable and how much the project has been able to do with those resources. In my view, on providing a stability and what it does for the community itself. So now this is the other stuff that I'm going to. This is a transitional piece. I just want to go. How can somebody maybe use some of this stuff? So the base framework is contained in core, so it's available for everybody. If you want to know where everything resides, it's in the metalib OEQA, and it's done by directory. So build perf is in there, runtime, self-test, SDK in the manual. So if you want to look at what they look like, that's where it is. The framework can be extended. So any layer can extend these tests or add their own. Just follow the same directory structure that core has, and it kind of picks up auto detects, I guess, or auto loads those things. If you want to see some examples, Meta Open Embedded has a few, Meta Intel and Meta Security, if you want to see how people have done it. If you want to run these tests yourself, it's basically adding inherent test image. You build your image and you can run with the C flag saying test image, and it goes off. If it's a virtual target, it'll actually invoke QEMU and start running the tests that we do. In the default is all tests that are available, so you'll see a lot of skips and whatnot, and it'll just sit there and run. If you're running on real hardware, and I actually do this at home, is you can define your test target IP address and the test server IP address. And so then it actually, if your machine, it'll then actually talk to your real hardware and run the same tests. So and that's what comes out of the box with Core. So I think it's phenomenal that all that exists, and it's fairly straightforward and easy to use. So that's kind of what I had, but this to me is the beginnings of the next section, which might be diving deeper into how to write tests and things of that nature. But I just wanted to give people an idea of what the project actually is bringing to the community at large, and how phenomenal it is with the limited resources that we actually have. So thank you very much.